Welcome back everybody to Tony's Top Tips Workshop. This is just a follow-up to the Sainsmart Genmitsu CNC 4040. I've had quite a few requests on, I had mentioned in previous videos that I want to upgrade the spindle, which I have done, and people's asked me what did I prefer, how have I done it, and this is just exactly how I've done it. I will go down into the workshop and show you on the machine running. Also in the description I will put a link to all the parts that I've used in order to get to this stage. So the first thing is I built a box. There's a lot of YouTubers that do the upgrade of the spindles, but you just see the power pack and the load of wires, and I can't do with that. I just can't do with a mess like that. For me, it's got to look professional, as though it came with the machine. It's not hard to do. I'm not an electrician or electronics engineer, but I just researched and did a little bit of investigation, and I've learned how to do it. And this is my way that I preferred to do it. People will have different ways of doing it, but this is my way and this is what I have done. It wasn't overly expensive. I'll just tell you a little bit of information into regards to spindle. I went for a 500 watt AR11 collet spindle. It was purchased from Amazon, and you get the motor, the spindle motor. You get a motor mount, which is completely no good to me, but it's a good motor mount. You get a full set of, I think it's about 11 collets, full set of collets for it. And of course you get the power pack somewhat. Now what I must say on the power pack is it's not in the sense it reduces mains voltage down to a voltage what you can use. It's 100 volts is this motor. A lot of people think they're getting a 48 volt, and it's not. It's 100 volts. And I ordered one from Amazon. It came. I think the cost of it was about, give or take, £100. The first one came and it was faulty. It worked for about 5 minutes and then just stopped working. But with Amazon, it's one of the easiest things to return is an item from Amazon. So I returned it and I requested another one. The second one came, that worked fine. And it's when you look at it, it's I'll show you in a moment exactly what I've done. It's pretty simple to wire up. There's a diagram for it, and basically there's mains in, which is, there's no earth on it, which I don't like anyway. There's a positive and a negative mains in. In my case it's 230 volts. And then next to that is your spindle connection, two connections, a plus and a minus. Next to that is your switch, and that is on or off. So if it's got a loop wiring, and that loop wire just keeps it on all the time, and it works from the potentiometer, the little pot that you get with it. I've discarded that junk wire. I've put it to a switch. I'll show you in a moment. And then the next to it is a 3 connection. It's like a little green plug, and that is actually a potentiometer. Now when I looked into this, I tried it, and sure enough it goes from nothing up to maximum RPM, and it says it's 12,000 RPM. So I didn't like that. Some people have put a voltmeter on, connected it in line, and then said that, well, when it's, and I checked it, it's actually giving out, is this actual power pack are giving out 104 volts maximum, which is, it's okay for the motor. And I found out, since it doesn't appear to be a brushless motor, the brush is inside it. But that's beside the point. It's the motor I wanted. It's reasonably quiet. But what you find out is, a lot of people say, when it's running at 60 or 50 volts, it's giving you half the RPM, 6,000 RPM, and so on. So you can judge it by the voltage to the RPM. That's not right. Trust me, it isn't correct. What I did, well, I didn't like that. So when I finished wiring the box up, what I did was I connected the motor up, put it to 0, put a mark where the actual indication was, and I put it on the case in pencil. That's 0. And what I purchased, and I purchased it from Amazon, there'll be a link to it in the description, is a digital tachometer. So on the little fan at the top, you put a little silver strip. And what I did was, I turned it up to maximum, from 0 up to maximum, and calibrated it. And it was actually running at maximum at 11,500. So there's 500 RPM difference, which is, it's not a great deal, but in some sense it is 500. It's not just 100 out, it's 500 out. That's the maximum. So I knew then, I put it back to 0, so I put a mark where the maximum was, 11,500. I just put 11.5, and then I worked every 1,000 on the tachometer and put a mark. So the gauge goes up by 1,000 RPM, right round to 11.5 from 0. So I'll show you in a minute. And that's how I judged it. So I know that when I turn it to 6,000 RPM, it's doing, give or take, it fluctuated a little bit, but it kept within 10 RPM, so it was pretty accurate. So I did that method, which is, to me, is the best way of doing it. Not by voltage, but by the RPMs. There was none of the equipment that I bought to do this expensive whatsoever. In fact, some of the packs of switches I got, you get 10 switches in for £7, and you know, so, and they're all rated at what they should be, or possibly overrated. So right, what I'll do now is I'll take it and show you the box. Right, here's the box. Now it's not the same colour, but it's blue. Now that's the front of the actual box. Now what you can see there is the potentiometer, and you have this is all metal barring the plastic rims, so and it's vented at the sides. That's the potentiometer, and that's what I was on about, from 0 down to 11.5, and underneath it's, those figures are singular, but underneath it says times 1,000. So that's the potentiometer, and it's all labelled up. That's the spindle on and off, and you'll see me down in the video that I do down in the shop using it, is you can be round at 11,000 RPM, and then you see something, you can immediately knock that spindle off. You don't have to turn the dial down, but it stops. So that's why I did it, as opposed to just working on that. It's got a kill switch. That's just a spare one. I put one in just in case I needed to put a fan on the motor, but I explained something else down in the shop. This is a case fan, so that brings the case fan on. That's vented, and that's the case fan at the rear. And because you've got it's very difficult to find a case fan that works off 100 volts, and I didn't want to work anything else off what the spindle comes off at, because obviously if you worked off that, it'd vary the speed. Well, I didn't want that, so I purchased a 230 volt case fan, ventilation fan. As I say, it wasn't expensive. It come with the guard and everything, and that is just switched from there to the mains on the board inside, and that is just an illuminated power switch. So that puts the power on, then it's all active, and that'll kill it. That's the vents on both sides, and it has rubber feet. Now, because this is what I was on about, is about a lot of things you get from China, the spindles from China, the boards from China, possibly all this is from China. The earthing to me is either non-existent, but anyway, I like to have it earthed. This is all metal. That's the power in, and you need one of the gland grommets on, so you can locate the cable and lock it off. That is the spindle connection. Now that's a 3-pin connection. I could have used a 2, but that's a 3-pin pushing connector, and you screw it on. That's down on the machine now. Now I've done that because that 3rd pin is an earth, and the cable I've used is pretty flexible, and it runs, and I am going to earth the machine, because what I don't like is you're talking, it might only be 100 volts and 24 volts on the other, but at some stage this power pack in here could go faulty, and it could end up giving me more than 100 volts or short out, and I don't want that. So safe wise is incorporate. You don't have to use the earth wire, but if it's there you can use it, but I am using it. It's just got a plug-in connector on the other end on the machine, and that's a unit. Quite nice and neat. It's, as you can see, that's a screwdriver, and it's about, well, I would say it's about 9 inch long by about 8 inch tall, and about 8 inch wide. They're only rough measurements, but I'll show you inside it then. And of course it just goes to a 13 amp plug, but it's fused at 3 amp. And to get into it, the front covers, the back cover and the front cover, do come off by 4 little screws. 1, 2, 3, 4. Same at the back. Now the holes I cut in here, I think they're 20mm holes, and the pot isn't 20mm, it's about 10. Right, here we are. Right, I'm taking one screw out. There's 4 screws, as I say, 2 either side. Put them to one side. I mean, the case itself, I looked around for the size of I didn't want it too big, but the power pack that you get with the machine is only really small. But I wanted enough room around it and a bit of cooling as well, so just like a computer case, as you say, it's metal. So right, now this is inside, and you'll see that. I'll see if I can. Yeah, but you can see the cutout at the back. That's for the fan. I just did that with like a pair of tin snips. I think they're 15mm, and that's about 15-16mm holes you have to drill. And as you can see, that is a very small power pack. And of course it needs to be all neat as well. So it's all cable tied up, all safe, clipped, and proper crimping connections. Now if you can see in there, can you see that? That's your negative, your live 230 volts mains in. Them two are your spindles, negative and plus and minus there. That's your jumper, which had a little loop wire in it there. You see that, everybody? That had a little loop wire in it. Now it's to a switch. And there's your three connections for your pot. Your mains comes in and it's switched to the main switch up there. I wouldn't instruct anybody how to wire theirs up. I've done mine. I think you can be on dodgy ground if you tell people this is how you have to do it and they get it wrong and then blame you. I can only say how I've done it and how it works for me. Now, as you can see through there is quite a space, so the fan blows through the vented parts of this, then out of the sides, so it keeps it cool. So there's no reason why this should overheat whatsoever. And as I say, when you look inside it, it's all nice and neat. Give you another look. And that's, to me, that's how it should be. Not that just screwed to a piece of wood and cables running round to it. There's a lot of people showing you how to do things. It's everybody's choice, but I can't cope with that. I have to have it where it looks neat and looks professional and looks part of the machine. When you see this at the side of the machine and working, you can understand why I wanted it like this. I mean, it does come with a test certificate. There's a power pack, but as I say, the first one went dead on me. But as Amazon do, it's the easiest thing in the world to exchange it. So that's how simple it is. I'll plug it in, and then you can hear how noisy it is. You will see it running with the actual spindle. I'll take you down into the shop and I'll show you that running. I'll just put this on just so that you can hear it. Now, as you can see, that switch illuminates. That means this is all live now inside. And if you can see inside there, let's have a look, see if you can see it. There's a little red light. That's on the main board. That just shows you. There is a green light that when you turn the pot up, it will go to green. But I was going to link the actual red lights onto a panel. I might still do that yet. I can basically do what I want with the panel and add to it inside. So then that pot will not work now. It wouldn't work because that's not switched live. When I switch that and then turn that will actually activate the spindle. But this is the case fan, and that's it. And it's quite, you can feel that. If you just bear with me, this is how it should be. Piece of tissue paper, off. Nothing. You see that? Nothing. that's the airflow through that unit by that little fan at the back, and it's out of both sides, so it's actually pressurising the inside of that and keeping it cool. And if you're talking about running a spindle for an hour, a couple of hours, then it needs cooling, or I think so anyway, than just left as a board. It makes the components last longer to me if they're cooled. So as I say, that's the panel. I'll just show you inside now. I'll put the power back on. You can see the red light now. You see it? That's the red light. And then if you look over there, I don't know if you can see that, you see just a faint green light come on right at the other end. That's just telling you, you might not be able to see that, it's very difficult, it's inside. They're actually on the board, so whether I can get a light and get a feed off it to put to here, I don't know. I probably won't bother, because it's not something that I'm particularly bothered about. And that's the case. I'll put the screws in a moment. I'll just face you back up to me. Right. So as I say, this is how I've done the project. That and I had quite a lot of requests on it, and I thought about it and what I wanted. And as I said, I'll reiterate that I wanted something that looked part of the machine, something that were quite functional, it was safe, and I'm not so sure it's 100 volts that it would have been safe just to have left it as that power pack screwed to a piece of wood. It needed some sort of container. I could have 3D printed one, but it wouldn't have looked like this one does. And as I say, we're going down to the shop now, and I'll just run a little program just to show you it working and how this connects up. And then the one cable that goes back is quite flexible, 3-core, I think it's 0.75 wire inside, so it's quite adequate enough. It's probably over, and it's just cable tied to the existing cable that's there, and it runs along that. But at any given time I can take that spindle out and put the original one back in and leave it and connect it back up. So there was an issue with somebody saying about cooling. His motor overheated after about an hour. Well, not overheated, it got very warm. So he took the, and I explained it down in the shop, he took the actual fan off the top of the motor, because he said it was a little bit out of balance or a bit of vibration. Yes, there is a little bit of vibration, but for what you got for your money for the spindle. And I tried to do it within a budget, because not everybody can go out there. I could have got a spindle at £350, you know, that went up to 20,000 RPM. It had its own inverter. Yeah, we've not all got that sort of money. I certainly haven't. I try and work to a budget. And he said he'd taken the fan off, and he'd installed a small fan above the actual motor, mounted it and wired it, and that runs and constantly blowing air at it. But that isn't the problem why the motor overheats, and I actually show you down in the shop exactly what the problem is with it. The fan isn't a fan, as you know, with offset blades that are at an angle so that it draws air in and throws it out. It's just like the straight blades inside the fan. So it just creates a draft and throws it down at the motor. But it is the same diameter as the motor. So what happens is the air comes through the fan, it hits the top of the motor, and it's distributed, get it out, it's distributed outwards, but it's deflected at an angle, so it doesn't go past the walls of the motor, which need cooling. So it's only the top plate that catches it. So what it needs, I'm going to 3D print one actually, and that's for a later video, and it'd be a shroud that'll sit round the motor with a space between the motor body and the actual shroud. But at the bottom of the shroud it will be vented, but it will be large enough to go past slightly the motor at the top and slightly past the fan. So any air that's drawn in by the fan has to go down the outside of the motor and out at the bottom, hence cools it. It isn't that the fan doesn't work, it's deflecting it, and I show it by when you put a piece of tissue paper near it, you can see it coming off at an angle, and that's why it only touches the top plate of the motor. Because on a lot of electric motors they've cooling fins and they've a fan inside which is blowing air, and it's designed, the shroud draws it and fires it down the side of the motor. This doesn't happen. It hits the top and blows it out that way. So anyway, I've whittled on long enough. What I'm going to do now is I'll take you down into the shop and I'll show you it running, and you can make your own conclusions from that. So until we get out of the shop. Right, here we are, down in the shop now, and I've just set it up for a quick demonstration. This is the new control box. This is one that I've made up. As you saw from the previous part of the video, the workings of it inside and how I set it up. There are links down. I'll put the links down below to all the component parts, and then and then this, of course, is the 500 watt spindle. Fits lovely, 52mm diameter, so it works the actual standard fitting with the sleeve out up to its maximum 52. Show you, this is the box, and that's how it's wired in, and this is the cable in there. So what I'm going to do now is I'm just going to do a quick setup. I've zeroed the X and Y axis, so it's just going to do the standard cut for the test engrave, and it's just engraved Sainsmart. So I'll set that going. Now this is all I do is the program's in, ready to run. Put the power on, it illuminates. Chassis fan on, because that power supply in there, as I said previous, is 100 volt. It gives out 100 volts to that motor. It's not a 48 volt one. So you need to add a little bit of cooling inside. There's a fan on the back. That's just a spare button. They're all labelled, and this is a spindle. So this replaces a jumper lead that's actually on the power pack. So I've just put a switch in, and these here, as I said previously, when I went into more detail, they're all numbered, and it's times, you can see underneath, times 1000. So that's 0, that's 500, that's 1000, right there up to, it says that spindle goes up to 12,000 RPM. It doesn't, and I've double checked it. It goes up to a maximum of 11,500. I know that because what I did was I purchased, and I'll put the links in the description down below. if you can see there, there's a silver strip. I actually purchased a tachometer, digital one, and what I did was I made the sticker. These are all put on. These are all vinyl stickers, vinyl cut. What I did was I actually placed a pencil mark at every near enough 1,000 RPM, right the way up to maximum, which is 11.5. Then I've transferred that on there, so I know that when I turn that dial to 6, there it's running at 6,000 RPM. As you can see, it's running. Take it up to its maximum, and it's reasonably quiet actually. There's a slight little bit of vibration, not much. And as opposed to turning the dial down to turn it off, I can just knock the switch. It kills it straight away, which is another bonus. You don't have to get hold of the dial and turn it down. So, as I say, I'll set this running now, and then we'll see what. I only set this about 11. It's got an engraving bit in. As I say, this is just a test cut, that's all this is. I've done others, but this is just engraving Sainsmart on a bit of old plywood, just to show you the motor up and running. And the connections here, I can pull them apart, and at any given time I can change over to the actual original spindle. So I can just unplug that, put the sleeve in, put the original one back in, and then that's it. But you can see, now this is a spare, it's an earth wire, because the new box I made is earth. Right, so there's a conclusion to this little project. I hope everybody's liked what they've seen. As I say, all the components for making this panel, it weren't expensive, and I have quite a number of, because you buy a pack of switches, a pack of connections at the back, the dim plug, so you've still quite a few left, so it's just cheaper to buy them. They will be linked in the description, and I do hope that people will be like it to be heard. Just in case. Also, on actual YouTube, there's quite a few people that say that the motor gets quite warm. Well, that's pretty cool, and I've had it running for like half an hour this morning. It was just warm to the touch, that's all. That it was overheating, so what they do is they actually take the fan off because it's slightly out of balance, and they replace it. Not with anything on the shaft, which reduces the back. Now that's finished. It's completely stuck. So I can immediately kill that spindle and just turn the RPMs down. A lot simpler. And it will do most things. This, as I was explaining there, a lot of complaint about this fan being out of balance and it gives vibration. Well, yeah, it might do. but what some's done is taken this off and actually built a unit here with a fan on the cells. Now if I wanted to do that, I could do that, because the original wires there, it's a 24 volt power pack in there. You could buy on the original board, I could buy a fan that's 24 volts, mount it on here, 3D printer frame, and mount it so that it's got a tunnel down here, and then that would enable the cold air to be passed directly past the fan, now past the motor. Now I don't think that's the problem with these over here. I think it's because the fan disperses the air, a lot of it here. When you run that, I'll just show you. Put a little bit of paper. Can you see that? How it's more there than it is there, and that's because I think it deflects the heat from here, from the fan, off here and out, not down there. So what would be the answer with this motor? Because there's nothing wrong with the motor. The amount of fat air that's coming off that should keep that cool, but it's coming off at an angle. What it needs is I'm going to 3D print something that goes round with some vent holes at the bottom that comes up slightly higher than the fan, so the air has to pass down and out at the bottom, so it's like a double shield, but it's cool inside. That's what it needs. I won't be putting a fan on unless the fan's that out of balance, but I don't think it's that much of a concern. Turn it off again. Right, let's brush a bit of this off. Now I hope you can actually see that. And I did one earlier which was there, as you can see. And that was, you can just see that's a little bit of a light engraving that I did, because it is only an engraving bit. And it would just to run it, as I say, it runs perfect as this machine. And I do hope that if anybody does take up the idea of using a box like myself, which I think is the way to go. I mean, there are quite a number of people on YouTube that do you know, spindle upgrades and what have you, but they have the power pack showing, and it's not, to me, it needs something. This makes it look more professional, and it's blue. It's similar colour to the original machine, so it doesn't look out of place. There's one cable that goes to the spindle. It's all nice and neat, as you can see from the back. That's it, power in, and your dim plug. You can take that off so I can move it about. Just unscrews as that. But yeah, I'm really pleased with it. Now at least now I can, as I say, what I intend on doing next is printing a 3D cover for the fan, so the fan works a bit better. I shall do that, and when it's complete, and I shall show you that that little upgrade. And the next thing I will be upgrading, which I will show you, is the bed. I'm using aluminium T section, and I think it works out around about £70 for 3 pieces. I think they come at 180mm wide by 15mm. I use this as a template for the holes to secure it down with, and then with plenty of threaded parts to choose from, so it's not too bad. And that will give it a more stable base, because there is a slight bit of flex there, as you can see there, but it's not much. And I'm just using 4 clamps, and what I use now, that's a thing that if you've got one of these, is you need to I sprayed a dry silicone lubricant on here, on the shafts and the lead screws, and it just keeps it lubricated. So what I'm going to do now is I'm going to go back upstairs, take the machine back upstairs, and I'll chat to you from there. So bye for now. Right, welcome back everybody. You've seen the video down in the shop. You've seen the machine doing a quick engraving, the word Sainsmart, and basically that's how neat and how it looks alongside the machine. It looks as though you've bought that with the machine, and as I say, everything that I've used will be down in the description. And believe it or not, I purchased everything off of Amazon. And the cable, a lot of the cable I use, the 3-core cable that you get with like a kettle or a computer. It's got the right size cable inside, 0.75, so it's more than adequate. And I use those. I use what I had, and I don't think the motor was the most expensive. You say £100. The case was, I think the case was about £30, and then you've the switches and the fan was about £19 and that. But I produced the power pack and the uprated spindle for less than £200, less than £200. And as I say, I have a lot of bits left because there's some of the switches and that I got 10 in a packet for £7 something. I'll do a proper costing for it, and then people know exactly what it's cost me and if they wanted to do this. But please, listen to what I'm saying is, you know, I'm not telling you how to wire your own and what you need to do. All I'm showing you is how I've done it, how the project worked for me. It works well, it looks good, it wasn't that expensive, but it's safe. And that is the one thing, that's my priority, is to make that safe, the power pack. I didn't like connections where you can touch them like that, so they needed to be enclosed, and I found that this was the best way to do it. So I hope you've all got a little bit of enjoyment out of this video. When I print the shroud for the spindle, I will show that as well, show it working. So don't forget, like and subscribe, because it's a bit of a reward for me from when people like my videos and subscribe. And as I always say, is be safe, be careful out there, and until next time, bye for now.